The second ToDoodle for today, we've done most of it, but now the games are done, so I want to do a little recording. The warm-up noticed that if you're trying to add 3s and 5s, you can actually make every number on this grid except for 1, 2, 4, and 7. Because once you got a block of 3, 8 is 3 and 5, 9 is 3 3s, 10 is 2 5s, then you could add a 3 to all of them and move that block like up to the next block of 3. It's like you had a rubber stamp and we're just stamping by 3s. So here was an example where we had 11, 12, and 13. And by adding 3 to each of them, we get 14, 15, 16. So you can just color in the whole thing that way if you wanted to. We talked about factors again, and we played the factor game with X's and O's. Then we played subdivvy, but now we're going to talk about this. So the games we just skipped over real quick on the video, why did we play those? Why do we care? What are all the factors of a number? When will that help you? And the answer is reducing fractions. And we're not officially on the fraction topic yet, but it wouldn't really be a good teacher example for me to give you a practice at doing something and not show you why you care. So we're going to pretend we're on fractions for a moment, even though this isn't part of the homework or anything. So somebody grab the grid that's on top of this rectangle and see what happens to 4/6. Right now you can see that 4 of the 6 parts are shaded. Ta-da! So we have turned 4/6 into 2/3. Now we have a rectangle with 2 pieces that are shaded out of 3. And you can see on the number line, 2/3 and 4/6 are the same. They line up. So how would you do that? How you're normally used to writing that is that you have the 4/6, and then you're going to divide the top and bottom by the same amount. And then 4 divided by 2 is 2, 6 divided by 2 is 3, and that's your answer. So if you are good at looking at numbers and seeing what the factors are, you can do this process a little bit more efficiently. If somebody gave you something that instead was 18 over 42, then yeah, you can just use 2. These are both even, 2 is going to work, but maybe there's something better than 2 that will get this done faster. And when I say better, I'm meaning only fewer steps. I'm not meaning that in any moral sense that doing this in fewer steps makes you a better person or better mathematician, or you will do better on the GED or any of that. But sometimes it's nice to have fewer steps to whittle down these fractions as we reduce them. So that's when you want to look at 2 numbers and say, wait, what are all the factors? Which factors might they share? So we'll get to that in a little bit later this term. As the last bit, sometimes you need to find all the factors of something. So games like these, how many ways can a cashier make change? If somebody gives you a 20, you could give them 4s, you could give them 5s, but not $4 bills. You give them $1 bills or $5 bills or $10 bills. How many ways can a marching band line up in rows? That looks a lot like this picture. If you have 12 things, there's only 3 ways to arrange the band. You can make them this way, that way, or this way. And there are other rectangles, but the other rectangles, again, like we showed last time, are just the same as this rectangle, but we turn it. So as they're marching around, then these aren't really 2 different rectangles, because once they turn a little bit, one turns into the other. So that's an all the different factors kind of thing. How many ways can we make rectangles with a bag of tiles? Those are ways when you want to find all the factors. Sometimes that's not what you want when you're trying to add fractions or make unbreakable codes. then you want what's called the prime factorization. And I'm not going to talk about that now. It's not really something we need, at least not yet. But as a homework, if you have time before Thursday, search for prime factorization and look for a video about it. It's probably something you've seen before long ago. Is it new to you? If it's not, what did you learn? What did you relearn? Because it's been so long and fled your brain. Then see what prime factorization is. But just for now, be aware that these are very different games. If you're finding all the factors, you're not finding the prime factorization. And if you're finding the prime factorization, it tells you some of the factors, but not all of them. So based on what kind of thing you're doing, you'll need one tool or the other. There's no magic tool that answers both kinds of problems.